You're on.
We're group 7, chapter 7, chemical reaction. The three chemical signs of a chemical reaction is formation of gas, formation of a solid, and release of energy.
Chemical equations have a reactant and then a product. One is CH4 plus O2 produces CO2 plus H2O. And then a balanced chemical equation is CH4 plus 2O2 produces CO2 plus 2H2O.
There are millions of possible reactions, but these are the main three: synthesis reaction, decomposition reaction, and single displacement reaction.
A bottle of carbonated water with the top is equilibrium. Carbonated, when removed, water is no longer equilibrium. That's it.
Yay! Go stand together so I can get you all together. Yay for group 7. Woo! All right.
My name is Trent Daniels, and I am a freshman Mr. R's third period integrated science class in my group, and I were assigned to Chapter 7, Chemical Reactions.
Chapter 1, Section 1. Section 1 is the nature of chemical reactions. So, chemical reactions, and range of atoms. Energy in reactions. Energy must be added to break bonds, forming bonds. Releases energy. Energy is conserved, release energy, and exothermic reactions that absorb energy are endothermic. Exothermic. Photosynthesis and whatever reaction. And my name is Tyler Landry.
My name is Josh Rowell, and this is Section 2. Section 2 is about chemical equations describing reactions. A chemical equations show products, any reactants. Balanced chemical equations account for the conservation of mass. Balanced equations have more ratios. More ratios tell you the relative amounts of reactants and products. More ratios can be converted into masses.
Light is bright.
Hi, my name's Kayla, and Section 3 is about reaction types, classifying reactions, synthesis reactions, combined substances, decomposition reactions, break substances apart. Combustion reactions are oxygen as a reactant. In a single displacement reaction, elements trade places. Alkali metals undergo single displacement reactions. In double displacement reactions, ions appear to be exchanged between the compounds. Electrons in chemical reactions, free radicals have electrons available for bonding. Electrons are transferred in redox reactions.
My name is Anna Cry, Section 4, Chapter 7. Section 4 is about reaction rates and equilibrium. There are factors affecting reaction rates. Most reactions go faster at higher temperatures. A large surface area speeds up reactions higher than concentrations of reactants react faster. Reactions are faster at higher pressure. Massive, bulky molecules react more slowly. Catalysis speed up or slow down a reaction but is not changed by the reaction. Enzymes are biological catalysis. equilibrium systems are when a press goes in both directions.
Say catalyst.
Catalysts.
Is that it? Yay! All right, let's get out here. Way to go, Tom.
We are in Mr. Rasmussen's 4th period integrated science. I'm Annie.
Elizabeth. And I'm Delicia.
We did chapter 7 on chemical equations.
Okay, section 1, nature of chemical reactions are form of gas, formations of solid, and release of energy.
In section 2, we did chemical equations, but the rundown of chemical equations were how to balance them. And on our poster, we have a chemical equation H2 plus O, and that would be the reactants, no, the products, no, reactants, it'd be the reactants, yields H plus O2, but that's unbalanced, so that equals a mad scientist. So to get it balanced, we have to add 2 more oxygens on the reactant side and 2 more hydrogens on the product side, which would equal H2 plus O2 yields 2H plus O2, and that equals a happy scientist. And then in section 3, we did the different reaction types, and the different reaction types are synthesis, which is A plus B yields AB, decomposition is AB yields A plus B, and single displacement is AX plus B yields A plus BX. But an easy way to remember that is in the first part it's AX plus B, and the second part B takes A's X, so it'll equal A plus BX. And then there's double displacement, which is AX plus BY yields AY plus BX. And if you remember single displacement, A had the X first and B had Y, so A got back at B by taking his Y, and now it equals AY plus BX.
And then section 4 was 5 things to speed reaction rates, and the first one was increased temperature, then increased pressure area, increased surface area, increased concentration, and catalyst.
And that was section.
All right, let me ask you one question. Let's say if we have a reaction that goes all the way, no, doesn't go all the way, only goes part way, and then we change one of those 5 things, will it force it back the other direction?
Yes.
And we show it with an arrow going both directions?
Yes, which was in equilibrium.
Yeah, very nice. All right, well done. Let's hear him applaud. Action.
I'm William. Shane. This is Seamus, Tyler, and that's Dylan. We're doing chapter 7, and we are doing chapter 7 chemical reactions. The sections in this chapter are the nature of chemical reactions. Number 2 is chemical equations. Number 3 is reaction types, and number 4 is reaction rates and equilibrium.
Section 1, the nature of chemical reactions. The 3 visible signs of a chemical reaction include formation of a gas, formation of a solid, and release of energy. And reactions that release energy are exothermic, and gasoline is involved in exo. And reactions that absorb energy are endothermic. Photosynthesis is in endothermic. And that's it.
That's it. Alright. Section 2. Chemistry is its own language. Chemical equation shows productions and reactants. Balanced chemical equations account for the I don't know what that says, I'm gonna skip it. Blank of mass. And
Section 3 is reaction types. Synthesis reactions, combined substances, decomposition reactions, break substances apart. Combustion reactions use oxygen as a reaction, and single displacement reactions, elements trade place and double displacement reactions, ions appear to be exchanged between compounds.
Section 4 is reaction rates and is that what? That hard one I can't pronounce.
That's temperatures.
That one. Oh. Most reactions go faster at higher temperatures. A large surface. What's that word?
Where? Surface.
Okay, surface speeds up reactions. Higher
Concentrations.
I still can't pronounce it. I'm gonna skip it. Of reactions get faster. Reactions are faster at higher pressure. Massive, bulky molecules react more slowly.
Yeah, we're in the 7, the last one. Here we were balanced chemical equations. We know why they're equations. If they give off energy, they are exo. If they take in energy, they are. Gasoline is exo. Photosynthesis is. All right, everybody got this and the graphs and how that looks. Now, do we have to balance? Yes, we got to balance them because really all a chemical reaction is a reorganizing of the reactants into new products. But you still got the same number of each type of element, right, Des? So, yeah. Yeah. Oh, I didn't hear Des yeah, but that's okay. I'm not pressing for it too hard. Rates, how do we speed up a chemical reaction? Anybody remember? I had them over here. We copied them the last day. There are 5 ways to speed up a chemical reaction. Heat them up. Heat them up, yes, very good. Add more reactant? Yes, increase the concentration. How about a catalyst? If we put a catalyst in there, does that do it? Greater surface area, we grind them up. There was one other. They're 5. But I don't remember it either. And we're done. All right, was that good? Did you get something out of that? All right, that's what we have learned out of chemistry thus